It's a very interesting problem. What is the minimum concentration of SO4 2-? What is the minimum concentration of SO4 2- required to precipitate barium sulphate? Barium sulphate can be precipitated. What is the minimum concentration of SO4 2- is required to precipitate barium sulphate solution containing 1 × 10⁻⁻4 mole of barium 2+. KSP of barium sulphate is 4 × 10⁻⁻10. Watch closely now. You should understand the relation between solubility product and ionic product. Solubility product is the equilibrium constant when the equilibrium is established, as in the case of equilibrium constant and reaction quotient. Ionic product is when the ions are present, not the equilibrium established. Now watch closely. If this is once the equilibrium is set, it is KSP. Before or after the equilibrium set, it is ionic product. Now listen, if I say ionic product is greater than solubility product, what will happen? When ionic product is greater, M+ and X- are greater than Mx. So what will happen? In order to bring down the ionic product to attain the equilibrium, the ionic product value should become solubility product value. Therefore, precipitation will be favored. When ionic product is less and solubility product is higher, then solution will be favored. So, in this problem, barium sulphate is becoming barium 2+ and SO4 2-. Barium 2+ is 1 × 10⁻⁻4. KSP value is 4 × 10⁻⁻10. So KSP value is equal to 1 × 10⁻⁻4 into X. What is this X? So that the ionic product will be greater than KSP. So this X is equal to KSP 4 × 10⁻⁻10 divided by 1 × 10⁻⁻4. So it is 4 × 10⁻⁻4 mole. If you add 4 × 10⁻⁻4 mole and slightly higher, the ionic product will be greater than solubility product. Immediately the barium sulphate will be precipitated. So in order to precipitate something, the ionic product should be greater than solubility product. The same thing is applied in the qualitative analysis of inorganic salts. I think in the higher secondary you might have not studied that. The first group metal is lead, second group is copper, cadmium and bismuth, and the fourth group metal is barium. Copper, cadmium, bismuth, they are all precipitated as sulfides in acid medium, whereas barium and other things are precipitated in the alkaline medium. Why here it is in acid medium, here it is in alkaline medium? The solubility product of copper sulfide or cadmium sulfide are very less. So even a small amount of sulfide will be sufficient to precipitate them. So in order to affect the equilibrium, we are using the common ion effect, H2S dissociating into H+ and S2-. What we are doing, in acid medium, more amount of H+ will be there. So less amount of S2- will be there. Suppression of the dissociation. That less amount of S2- is sufficient to precipitate the copper bismuth, and cadmium. But when you go to the fourth group, more amount of S2 minus is required. Therefore, it is carried out in the alkaline medium. So more dissociation. This is called the common ion effect, which I will be explaining at a later stage. So